Hey everyone, I hope you all are safe and doing good. So from this lecture we are going to start array, that is the simplest data structure. So we'll be discussing our first data structure, that is array. First we'll see some like the basics of arrays. Although we have discussed basics of arrays, what is array, how to declare array, how to initialize array, memory representation of array in our Java course as well. But we'll see briefly in this lecture also, and then we'll move further like how you can what operations you can perform on array, and then we'll write them the algorithms and programs, and we will calculate time complexity and space complexity as well, right? So let's start. What is an array? I hope now you know this thing. In simple terms, I can say it's like a collection of homogeneous data items, right? But first let's see what why we need array. See, obviously when you are writing some programs, or when you are dealing with applications or developing application software, so every program needs some data to process. We know data is very important, right? How to store data now? Now, to process that data, that application or that program, and that data should be present in RAM. We know we have two memory types, like we have RAM, and one we have is that hard disk. You can say that secondary memory. This is primary memory, and whenever you are going to execute a program, that program must present in this RAM and the data as well on which the program is working. We know this thing. And basically this is how, like, the organization of the data or the arrangement of data here in the main memory is the data structure, is like taken care by the data structure you use. So we use the best data structure so that we can process we can perform the operations on the data in efficient manner. We can access the data easily, we can insert, delete, modify, or whatever you want to perform, you can easily do on that data. So that thing is managed by like the data structure, which kind of data structure you are using. So there are so many data structure. The very first is array. That is the simplest one, and it is linear data structure, we know, because elements are stored in a sequence. Okay. Now, if in short I say, now why how the data is to be stored in RAM? Because obviously if you want to add two numbers like 5 and 10, so how we are going to store? You need variable, we know. So it's like simply I can say int a is equal to 5 and int b is equal to 10, something like this. Simple. So in memory, there is like we have, these are local variables, because we are writing, like, suppose in main, or suppose we are having another method add, and within this we are having these two local variables for this add. I'm not writing the exact code, maybe some syntax error can be there. I'm just giving you a brief intro. So these are local variables to this add. So we know how the memory is to be used. Basically, like, in memory we are having like two parts: stack part, stack area, or the heap area as well. So heap area is used to dynamically allocate memory for objects, for arrays, or for objects, these kind of thing. Or stack is deal with method calls, or it stores the local variables of these methods. Okay, that is stack. So we know, like, RAM is something like this. We are having this. There are so many memory. You can represent something like this, like these cells. Each cell represent one byte, and there are so many bytes from starting. Suppose 0 to how much memory you have? RAM 4 GB, 8 GB. So till then, like 0, 1, 2, 3, 4, 5, and up to, like, how much memory you have, that depends. It depends on that thing. But that memory is also divided into some segments, some portion. So when you are going to execute a program, some segment is given to you. In that segment, your data is programmed, and that will be stored, and the application is going to run within that memory kind of thing. Okay. And we generally, like, yeah, we have, because we are not going to into we are not going into that much deep, but like the RAM address start from 0. So yeah, in some operating system it happens, but these lower addresses are used to store for some system functions only, for BIOS and these kind of thing. We can't directly access these things, so we deal with like higher addresses. Exactly, we don't know what is happening behind the scene, but it's just like I'm just giving you a general idea, right? So something like this, each cell is like a byte, and each cell, byte means it can store 8 bits. So something like this, we can, if you want to arrange, you can arrange something like this also. So this is like 0, 1, 2, 3, 4, 5. You can say that address of the cell, and here we can store 8 bits, 8 bits. In every cell we can store 8 bits, and every cell is having some address. Like it is in hexadecimal form. Generally, we consider in program like address is 100, 1000, 1024, this kind of thing. But actually, we know these are some hexadecimal form address, and we don't directly deal with addresses. So we just assume a simple value for simplicity purpose. So I'm assuming that the address start from 0 of each cell and go till whatever memory you have at the maximum of that thing, 4 GB, 8 GB, 16 GB, and 32 GB RAM, or based on that, right? So if I take one segment, so we can take like six from 0 to, like, we can take 65535, something like this. It's a small segment of the memory. So we'll deal with this segment only. We'll not take the complete memory. Okay. Each cell I know is having 8 bits. Fine. So when you want to store this int a is equal to 5, so some memory would be allocated. How much memory, how many bytes? Int will take 4 bytes, so 4 bytes would be allocated. Okay. Now this is 1 byte, this is second byte, this is third byte, this is fourth byte. So these 4 bytes, suppose these 4 bytes would be allocated. We don't know anywhere in the memory, but we are supposing these 4 bytes. Now this data is to be converted into 32 bits, binary number, and this is how this is to be stored. 8 bits here, 8 here, 8 here, 8 here. Okay. And we can see like address is somewhere, suppose for this byte address is 100. So we basically take that. In general, I'm not representing this in 4 bytes. I just generally represent, we are having some one cell, one box. Here we have this 5 and address is suppose 100. That's it. But here basically we are having memory space of 4 bytes. Yes. So these are 4 bytes. Complete these 4 bytes. Or you can represent, we have a RAM, something like this. It's a sequence of these bytes, something like this. It's a long tape of bytes, one byte, second byte, third byte, something like this. And these, suppose these 4 bytes would be allocated 1 2 3 4 to store this 5. So within this 5 would be stored, converted into 32 bits in binary form. Okay. So generally we don't represent this, we represent only one box, and this byte address is 100. So obviously the base address is 100. This byte address would be 101, 102, 103. So we take the address of this 5 is 100 because this is the base address, the address of the first byte. Okay. Now this is happening, how like we are dealing with memory and all. But all this is stored because these are local to this. So these are stored in stack memory. There is a part, or you can, it's an area in that memory that is stack. Okay. Logically you can have, but physically it's not like that. There is a particular lines divided in that memory is in two parts. This is stack, this is heap. No, but virtually you can imagine there is one area which is known as stack, one another area which is known as heap. Okay. That was like handled by memory manager and JVM in Java. We don't need to deal about these things, but mainly stack and heap are, I think, clear to you. So these are allocated in stack. Now what happens, this is one variable. Now I want to store 50 variables, suppose. Then it's not like that. I cannot store 50 variables without taking any. Obviously, the base thing is you need to take variable, and there we can store that value. This is name of the variable. This is data type. This is the, you can say, value, whatever you want to store into value. Int, float, boolean, or any value we can store. So what about, can we take 50 variables A, B, C, D, A1, B1, C1 and store 50 values? Maybe you can take this. But suppose I want to store 1000 values. So it's not at all a good idea to take 1000 variables and store these things. Okay, that's why the concept of array came into picture. Under the one variable name, now we can store 60 or 100 or 1000 same type of data, and that is array. Okay, now suppose let's take one example, a simple example. Take in my class, I have 60 students, so I want to store roll numbers of 60 students. Okay, so I cannot take like 60 variables and store a roll number of 60 students. I just take an array. So have to declare all the data type of the array and then the symbol. In Java, I'm just telling na. because we are dealing with Java only. The name of the array I'm taking roll number. Roll numbers is equal to, or let's take just equal to only. We are just declaring the array here. Name of the array, data type of the array, what type of value you want to store, and this symbol. So this symbol is of these brackets indicate that this is an array. This roll number is an array basically. Okay. Now under the one variable name, I can store roll numbers of 60 students, 60 values, 100 values, 1000 values. As many values you want to store, you can store. You don't need to take different variables. So that's like beauty of using array. We know like why we need array. So this is thing I think clear to you now. So but array is of fixed size. Once you fix the size of the array, I want to store roll number of 60 students. So at the time of declaration, this is just declaration. So in Java, if you are dealing, then arrays, this is not the, you can say that array are not the primitive type like int, float, double like this. No, array is a special class, and whenever you write something like this, so this is considered as simply a reference to the array. See, we have a class in Java. We have a class in Java, student. And if you want to, here we have name of the student, two fields we are having, and roll number. So how to create object of this student class? We simply write down this class name like this student and S1. Simple. And obviously this is just the, I told you, this is just the reference. It is not storing the actual data. To allocate memory for this, for this name and roll number, we need new keyword in Java to allocate memory. New, then the constructor we are calling student. That's it. Simple. Yes. So student S1 is just a reference. Actual object will be created where? In the heap. Dynamically. When you're using new keyword means you are creating some object, and that actual object would be created in heap memory. And this reference would be created in stack. We know. I hope this is clear to you if you have watched those basics of Java lectures. Same, arrays are also objects. Like array is a class, and when you create this thing, so we are creating like objects basically, because array is a class. So same, you are creating something like this. So you are creating object of this class. So we are creating object of like arrays class. So this is just a reference. No memory has been allocated to this right now. This is just a reference, right? And by default in reference in arrays, we are having, if this is instance field or in the class level, then this will contain the reference is null because there is no actual array object, right? To create actual array object, you have to write something like this. You have to instantiate this array. So roll number. So here we are write something like this. The name of the array is suppose roll number. Roll numbers is equal to. We use which keyword to allocate memory? New in C++ as well as in Java. New, and after new, you will write, sorry, not student, because the type is here student, but here type is int, although it's array, so int, and give the size 60. That's it. This is instantiation of the array. We have instantiated this array. Now memory has been allocated. Now actual array has been created, and size is how many bytes? 60 you want to store. Every type is int, so into 4. So how many bytes would be allocated? I guess 240 bytes would be allocated. Okay, so this is instantiation of array. This is just declaration, semicolon. So this is just a declaration. So this roll number, this roll number is just a reference variable. Roll numbers, this array name. I'll show you how the in memory it is to be represented. It would be in stack, and actual array would be in heap, and this will be pointing to that array. Okay. So now we have fixed the size. Now I can store only maximum 60 values, 60 int values, not more than that. So dynamically array cannot grow and shrink. Like in Python we have vectors. At starting, I have declared vector size 60, but at runtime, I just want to store 61 elements. So it will automatically grow. You don't need to do anything. Handled by the compiler itself. But in Java, it's not allowed in arrays. These are of fixed size. If you want to store, if you want to increase the array size, you can do one thing. After that, you can write roll numbers is equal to new int and 65. So this array would be discarded, a new array will be created, and the elements of the previous array would be copied here, and there is a lengthy process. Same array cannot be cannot grow at the runtime. Arrays are of fixed size. At the time of creation only you have decided the array size. So that's why it is saying array is a fixed size data structure. Array, we know, it's a linear data structure that stores a sequence of elements of same data type. In this array, we can store only int value. If you want to store float value, string value, you will get some error. So it will contain homogeneous data items, right? It's like a, you can say, container holding a set of values organized in a specific order. And in memory, arrays are stored in contiguous memory locations. Okay. How these are stored, I'll tell you that thing also. So you can say like array is something like in theater we have those seats. So there are like this row, this row, this row. There are so many seats. So this row one is known as array. Arrays are of many types. 1D array, single dimensional array, multi-dimensional array. This is single dimensional array. 1D array only, having one row but multiple columns. So this one row of seats is like a array, we can say, right? Stack of books on a shelf. These are also known as like array. Maybe you say that it is a stack, ma'am. You told that it is a stack. But I have told you that there are two types of data structure, physical and logical. Logical data structures are just like, we can say, if you want to implement that kind of discipline, then those are logical data structures. Those are conceptual organization. Actually, to implement logical data structure, physical data structures are used in memory, and physical data structures are arrays and linked list. So if you want to implement stack principle, LIFO principle, then you can use either array or linked list actually in the memory. So stack implementation using array, stack implementation using linked list. So that's why ultimately internally those stack of books is internally an array itself. That's why the example is given, a stack of books on a shelf. So these are some real life example of arrays in your classroom also, like, or in your seminar hall. That one row of those chairs or seats are, you can consider it as an array. These are in sequential order, right? I hope basics are is clear to you. Now we have done declaration of array, instantiation of array. Now how to initialize array? Let's see that thing also. And how these are represented in memory. So why we use array? Efficient data structure, simplest data structure, efficient data storage. Arrays provided a compact and organized way to store the data. And definitely if data is stored something like this, one after another. So in array, actually data is stored in sequential order. So if I have an array, suppose int, and I have an array is equal to new int having 5 numbers. So the memory would be allocated in a sequence, right? One number is suppose 10, 0, 1, 5, 2. So all the numbers are stored in a sequence, one after another. It's not like that this 10 is somewhere in the memory, this 0 is somewhere else in the memory, this is somewhere else in the memory. No, these are in a sequence in this data structure. So obviously, after this, if you want to access this, it would be easy because these are the closest with each other. If suppose in this, this is, you can say that grid of memory having cells, RAM. One data is here, one data is at the 500th cell. Once you want to access this data, then you need this data. So definitely this will take some time to access this data, although it may be nanoseconds because the computers are nowadays really fast. But second situation is data is here and next data is at the one location only. So definitely to access this data, less time would be required rather than accessing the data which is at 5,000 location. So that's why it gives you an efficient data storage structure, because objects data are contiguous with each other in a sequence, right? Direct access, you can directly access the data because we have a indexing kind of thing. So array index starts from 0, 0, 1, 2, 3, 4, something like this. If you want to access any element, you can directly access using index, we know. So just you have to write down the array name. Here array name is arr, and just index here. I want to store this, I want to access this data. So you simply write the index number 2 and it will give you 1. How the address is to be calculated, I'll tell you that formula also. This thing is clear. Arrays are started from 0. And why 0? I have told you in the Java course also, there are two reasons, historical as well as technical. So the very first language we know, like mother of all the languages, is like basically C. So the designers of C used this concept that they have started array with a 0, because in C we were having pointers, and in pointer arithmetic operations it is easy if you start arrays or the list with a 0 rather than 1. They analyze this thing, so they started arrays and list with a 0. And Java is, we know, heavily dependent on C language. So makers of Java also followed that same syntax, that uh, let's follow this consistency only. Let's start arrays with the 0 only. Otherwise there are some languages, I guess Fortran, Lua, R, in these languages arrays start from 1. It's not like that in every language array start from 0. But they followed that so this is like historical reason, they started that thing only, they followed that thing only. Let's keep it as it is. Arrays are started from 0 only. Okay, to make it consistent. And like list are also started from 0, so they want to make it consistent with other data structures also. So they make it something like this. Technical reason, one more reason I'll tell you. When you are going to calculate the formula to access any individual element, in that case also there is one reason, that is also a reason why they kept is kept it as it is, that let's start it from 0 only. But now for now you have to remember these are 0 indexed, means arrays start from 0 index. So you want to access, then you can directly access. So there is direct access or random access. Directly you can access any data. You don't need to go, like if you want to access 1, so it's not like that you have to go from here, like first access 10, then 0, then 1. No, you can directly access this one. There are like some in there is some shelf, and there are some books in this shelf, so I can directly that, if you want to pick, I can directly pick one book. So randomly I can access anything, right? Okay, fine. And we can traverse the arrays with loops and iterations. So I'll show you this point also, how to use loops. Now, characteristics of array, I guess till now you're familiar with array, so you can easily tell what are the characteristics of array. Fixed size, arrays can store data, homogeneous data items, like data items are of same type. And arrays items are stored in contiguous memory locations, one after another. Homogeneous data items. Indexed based access, we can directly access any element. Random access is possible using index. And arrays are 0 based indexing, means index start from 0. So these are few characteristics of arrays. Now we have array declaration. This thing I have told you how to declare an array. Just write data type. Two ways are there: data type, name, array name of the array, and these brackets, or the second. But in Java we generally prefer this thing. In C and C++ we write this thing. Okay, and in Java we recommend that you use this thing. You can use this also, this syntax also, it's fine, it will not give you any error. Instantiation of array, I have told you. Now array name is equal to new and data type and the size. So numbers is equal to new and int and the size. So this is instantiation, means right now memory has been allocated. In the previous case, in declaration, no memory has been allocated to actual array. This is just a reference variable to the actual array object. This is not actual array, right? Like if you take int a simple variable, so we know that I'm writing int a. So we know that this a will store the actual data, right? But this is not the case here. The numbers is not going to store the actual data. No, numbers is this name is just a reference to the actual array. Somewhere in heap, actual data would be stored, and this numbers is just a reference. It contains the reference, or you can say address of this actual array. This would be in stack area, this would be in heap area, heap memory. That's the difference. Because arrays are objects in Java. These are not primitive data types. Int is primitive data type, right? Now, instantiation is clear to you. Now, memory has been allocated to this array. And how? Let me just show you the memory representation also. So, we are having this kind of thing. Actually, uh, I guess you remember the JVM architecture. OS will give, whenever you run some memory or some part to that JVM, and JVM handle that memory, RAM memory, that part internally. So there in JVM, we are having heap, stack, native method area, native, you can say that method stack, PC registers, 4 5 things, right? So we are just, we can say, we just deal with stack and heap. So we don't know any other thing. We don't, you can so give some attention to those fields. So it's like we are having mainly three things. You will deal with mainly three things. So this is like code part or the code segment. This is stack and this is heap. How that segment is particularly divided. Visually, just I just remember, I just want to show you. It's not actually that there are some this kind of books and divided and all. So in stack, we are having that executed bytecode that would be loaded of that program. In stack now, whatever variables those would be local variables or the method calls that would be handled by stack, and dynamically allocated memory. This is heap. So if you want to create any object, then those actual objects would be created dynamically in the heap, not in stack, right? So in main, we are writing simple. Suppose we are having main function, string args, and here we are having an array. This array, int. So there are some statements, but let's see this thing only. So whenever you execute, JVM will first go to main. Main is a method, obviously. So that bytecode for this would be loaded here in this code segment of that memory in the RAM, because obviously to run this, to execute this program, that program has to be, or that machine code of the program, or here in Java we know we call it bytecode of that program should be in RAM. Then we are having the whatever data unit that should be in RAM. So that is like bytecode of the classes or the program here. Now in this we are having array. Suppose you are having one variable int a is equal to 5. This is a simple local variable. So in stack, this is one frame, or you can say main stack frame or main activation frame or activation record for main main method. For every method, one stack frame would be there in that stack, would be pushed in that stack. So here we have this is local variable. So we have a and 5 would be stored. Something like this is there in binary form. Next we have an array. Array we are creating dynamically because we know there is new. So whenever you got new keyword, dynamically this is an object, and the actual object would be created for sure in heap when you use new keyword. So arrays are object. Now how many bytes should be allocated? 5 into 4, 20 bytes. Numbers, this is reference. So this numbers would be here. This is numbers. An actual array would be created in heap. 1 2 3 4 5 for to store 5 values, and this number is going to point here. Something like this is happening inside the memory. Now whatever value you store, those would be stored here, right? The local variable is stored here only, but arrays are like, you can say these are objects. These are not simply local variables. So for that, heap, from heap memory, data is to be allocated in heap, and reference is here. So suppose the base address is 100. So for the next, it's 104, it's 108, 112, 116, because this is a 4 byte. Every data will take 4 bytes. So next is address is 104. So here 100 is to be stored. So it is pointing to here. Now, not only the data, you have to be very precise. There is some header also which stores some metadata about this array, like array size and any other information as well. But we don't actually care about those things. So we just say that this is the array would be stored and the reference is here, something like this. We don't will the header and all. So just leave it. But actually header is also there in heap containing some metadata about this array, right? But just leave that. So this is the case. This is the, you can say, memory representation of array, right? Now next, array initialization. So now there are many ways to initialize array. First is array initializer we can use. So this is known as array initializer. The values in these braces. So this is array initializer. While declaring the array in the same, you can just write down this thing. So array initializer is just like a shorthand to instantiate this array as well as initialize this array and declare this array as well. You don't need to write new and all. Simply you can write down this thing. Okay. If you want to write now new, so you can write down something like this. This is instantiation of array. Because see, while creating an array, 3 steps are there. First is declaration. Next, instantiation of this array. And next is initialization. Declaration, I have told you, simply if you write like int and this name of the array arr. This is declaration. Instantiation of the array is int arr and you allocate the memory int new and give some size 5. Initialization is you initialize, you give the value. So here, if you have done this thing, so directly you can write down here. We cannot simply write down arr is equal to the list. No, this will give error. You have to write down here array is equal to new int and simply here the list. Whatever value you want to give, you can give. Or individual, you can give this. So the first number we can access, the name of the array with 0 index is equal to 1. At first, it's 2. At second, it's 3. So individually, you can assign these variables, or at runtime only we can assign. We know we have a for loop and we can just run the loop from 0 till the array length. So array length is, there is a field in arrays length, so you can just directly call to get the size of the array here. You don't need to give here 5. It will give you numbers dot length will give you what is the size of the array. It will give you 5 and directly in numbers of I you can store here. We are storing here I plus 1. You can use here scanner as well. Okay, let me just show you now first. Till now, whatever we have done, practically declaration, initialization, instantiation of this array, and how to use array initializer and all. Memory representation, I have told you, stack memory, heap memory. It stores the reference variable that points to the array object in the heap. And in the heap, there is actual array object where the value is to be stored. Okay, so this is how actually. Now, basically, somewhere I have just uh, represented something like this. Here we have stack, and this area is like heap. This is heap area, and this is stack. So here we have like this is like main frame, main stack frame. So this is for numbers, and here we have actual array. So it's not like that these are in different parts or all. You can represent something like this, as well as the previously I have given you one more diagram. Here we have code part, code segment. Here we have stack. Here we have heap. So you can represent something like this or this. Both are same, right? How to access array elements? This also using indexing. We can directly access array name and just give the index. Now, before going to practically, let me just one thing is remaining. Let me just give you the formula for this element address. How to this the address of this element would be calculated. So there is numbers and this is pointing to this. So containing suppose 100. Actual this is some hexadecimal value, but we are just taking 100. So whenever you write something like this, whenever you write numbers and 2, means you want to access this. Index number is 2. Then how you get this? Obviously, this address would be calculated first. Then at address, whatever the value stored, that would be given to you. But how this address is to be calculated? We know the base address. Base address is stored in this number because number is the reference to this. So there is a formula. The formula is base address plus index into size of the data type. So in this case, base address or whatever there in numbers is 100. So it's like 100 plus index number you have given is 2, 2 into size of each element. You know the size because this is of the type is int. So we know the size. For each element, size is 4 bytes into 4. So 108. So what is there at 108? Just access that and it will give you 5. And that's the exact value we have, 5. Okay. So this formula is there to calculate the address of that particular element if you want to access with the index. I hope this is not like that much. So now that's it. Let's do some practical for this array declaration, initialization, and how to access array element. So in this project, data structure and algorithm, you have a package. So in this package, let's create a new Java class. And the name I'm taking is array demo. So in this, we are having simply, suppose in main, we are having an array. So how to declare? Int, and same we get numbers we are having is equal to int. So this is just the declaration. We have declared this array. If suppose you think that let's print whatever is there in numbers. Let's print numbers, this thing. So it will give you error. Might not have been initialized, this numbers. Because this is, we know that this is local variable to this main. So local variables don't get initialized by default. If this is a class level, suppose I'm taking rather than this, let's cut from here and paste it here. In the class, this is now class level variable. Okay. Now here, okay, you have to make it static to access it without creating object of this class in the main. Now there is no error. You can print these numbers, but what value would be printed? Let me just show you. Let's run this and see. This would be given the default value, and default value for this for references is null. So see here we have null because there is no actual object created. It's just the reference variable. So it is null, right? Now let's just take here only arrays. So let's now in the second line, let's instantiate this array. Means allocate the memory, new int and for 5 numbers. Now you can print numbers because actual object, array object has been created in heap and that memory. Now this numbers is referring to that actual object. So in numbers, we are having some now address kind of thing. So it will not give you the proper address. It will give you some hexadecimal hash table hash code type of value. So bracket, so it's an array. I means integer type array at the rate at this, you can say address, the arrays. Okay. Now what are the values? If you want to access, if you want to access numbers, whatever is there at 0th index in this array. You haven't initialized this array. So by default, the array has been initialized with zeros because default value for int is 0, right? For arrays, for objects. It's not like that in main we are having int a and that would be initialized by default to 0. No. If you print this a, it will give you some error. A. See the red line. Variable a might not have been initialized. So simple local variables, these are not being initialized by default. If this is instance variable, that would be given a value, default value 0. You can check here if you want to check default value of int in Java. So you can go to this Oracle Help Center, this website, and there you will get default values for these data types. For byte 0, short 0, int 0. For long 0L, for float 0.0F. For double 0.0 D. For string or any object. See, array I have told you it's an object. So for string or any object, it will be null. For boolean by default it's false. But local variables, see here, just let me show you. This local variables are different. Compiler never assign a default value to an uninitialized local variable. So this thing you need to remember. Let's delete this A. Now by default here we have 0, so it will print 0. See, it's 0. So all the variables, all the 5 variables are 0. Now initialize these variables. So third step comes initialization. So how to initialize? Numbers is equal to new int, and here just give the list. Suppose these are the variables. Now number 0, at 0th location we have 1, so it will print now 1. See, it's 1. Now we can do all the 3 steps in one step itself. You don't need to write the 3 steps. How you can do? Let's just comment out this thing and let me just show you. So simply this is declaration int. At the same line I can write new int. Rather than giving here size, simply we just give the value. Whatever value you want to give, you can give here. That's it. So this is array initializer. And if in this case, if you write here the size, you will get an error. If I'm writing here 5, see the error. Can you see the red line here? Semicolon expected this. If I run this, let me just show you the error. What is the error here? So array creation with both dimension expression and initialization is illegal. This is initialization and this is dimension expression, means you are giving the dimension, the size as well as the array initializer. So this thing is not allowed. You cannot create array with both the things, because with the array initializer Java will automatically handle or calculate the size of the array. So you can't give both the thing at the same time. Either you do this thing or you can do this thing. This is also allowed. You don't need to give that new and all. This array initializer will handle everything, right? So this array initializer, it's like a shorthand way to declare, instantiate, and initialize an array in just a single step. Just give the values in this curly bracket. That's it. So this thing is allowed, but this is not allowed. If I write here new int and I give the size 5 semicolon, and here suppose numbers is equal to this. You think that let's instantiate here and just use the array initializer and assign the values? No. So this is assignment. You are assigning in numbers this value. This is not allowed. Numbers is just a reference variable. So see the error here. Array initializer is not allowed here. Again, you have to write here new int and then it's allowed. Okay. Now you want to print, you can directly access this thing using this 0, 1, 2, 3, 4. If you want to access the array index out of bounds, suppose I want to access 6th index. Index is 0, 1, 2, 3, 4. And I want to access 6. Let's just run this. It will give you some exception, array index out of bound exception. See, in this array index out of bound exception at line number 6, the length is 5. In array demo.main, if you click here, you will get the cursor at this line. See, this is not allowed. So in I guess C and C++, there is no bound checking in arrays. It will give some garbage value, but here, yes, there is bound checking. So it's a great point for security and safety point of purpose in Java. That's why Java is like more secure. And if you do not initialize, I've told you the values are initialized with 0. And in C++, there the value, some garbage value would be initialized. So that is also not a good part. If you do not initialize, automatically it will initialize with 0, and that's great, right? So this is all about a declaration and initialization of the array. Now third point, okay, at runtime if you want to initialize, or directly if you want to initialize, suppose I don't have this array initializer. Let's delete it and delete this line itself. So I want to initialize individually. So numbers 0 is equal to suppose 8. So numbers x is first is equal to 5. Only 2 I have assigned at 0 index, at first index. Remaining index would have value 0. So at 0th now where we are having 8. So it will give you 8. So individually also you can assign the values to this. Now third is at runtime. See 8. At runtime, we know from user we want to take value. So we know we have a scanner class. So input is here from system.in because standard input we are taking from keyboard. So there's a scanner object. Now we are not assigning individually. So delete this. We have an array. This. So now let's have a loop. We know from 0. Let's start from 0 till I less than whatever the size of the array. So we don't know if the size, it's okay. You have a field dot length. See, it's a field. It's not a function. It's just a field, static field. You cannot write here something like this. Sorry. It will give you error. If you make it function, there's no such kind of function there in arrays. So this is just simply length and I plus plus. Now I know you are aware about loops and all. We have discussed this thing. So we'll traverse from 0 till length of the array and we will have numbers whatever the I at index is equal to whenever you take input from the user. So scanner dot next int. I want to take int as an integer. Before that, let's just print here enter array elements. That's it. Simple. And here I just want to access at 0th index what is the number. So what is the value? So let's run this. Now first you have to enter the value. See enter array elements. So we have entered 5 and it is giving you numbers at 0th index we have 0. Sorry 2. So it is giving you 2. So like this you can at runtime also we can you can say initialize the array. Now let's pause the video and think what is the time complexity for this program. Time complexity. See here these are some simple lines having constant time, right? So you can say order of 1 while creating the scanner object and this array for this array. Order of 1, that's it. So we don't much, we don't care about these things, constant time complexity. Now this line, okay, enter, we are just taking this operation would be performed only one time. Now we have loop. This loop will run till 0 to numbers dot length. Length means the size of the array. And that is in general case. Here we have 5. But if it's 10, so it will run till 10 times. If it's 50, it will run till 50 times. So we take general n. N. So it will run till n. I mean, this statement would be executed till n. N number of times. Till the loop is true. I mean, till the length of the array. So order of order of n for this. We are just printing this. So this operation would be performed order of 1. So everything is order of 1. This is order of n. So order of n plus 1, 2, 3. You can say something like this or 4. N plus 4 you can just ignore those. We know the constant. So the time complexity would be big of n only for this program. Okay. So now whatever program you write, you have to calculate space complexity and time complexity. Now what is the space complexity for this? Just a scanner object. So order of 1 only. Now it is array numbers. How much space or memory would be allocated? For 5 in values. So it's order of n. If it's 10, then for 10 elements. If it's 5, so it depends on the, you can say the size of the array. So basically space complexity here is also order of n. And here we are having one, this is input. This is input space. This is for input space. Auxiliary space is we are taking what extra space you are taking to solve the problem. We are taking simply one extra I variable to solve this problem. So for I, simply constant. So that is order of 1 only. It doesn't depend on the input size. It's simple one variable. It's order of n plus order of 1, n plus 1. So we can ignore 1. So it's order of n. So time and space complexity for this is order of n only. I hope now it's not that much tough. It's easy. So you can easily calculate this thing. And here if you want to assign, suppose not next int, I'm just taking next double. So it will give you error. See, provided is double but required is int. So whatever the type of the this array, you can store that type of variable only. So you have to take here int, right? But if array is something like this, I am having this thing. I'm having here numbers. Int numbers is this. Let's just comment out this thing. So we have an array this and numbers is equal to new int 1, 3, 5, 7. And if I just write here 0.9, see the error. It's double and required is int. But the thing is, let's change it to double. It's double now. So new, here also you have to change double. Now it's fine. These are double, but these are int. So it's not like that if you are taking an array of double, so every element should be double. See, we know that promotion is allowed here by default. So data type promotion is allowed. So int is smaller and double is larger. So when you take here int, it will be automatically promoted and it will become 1.0, 3.0, 5.0, 7.0. That's it. That's why internally these would be considered as treated as double as well. So if you access at zeroth element, what is there? So it will give you 1.0 because it will automatically be promoted to double. See, so these should be compatible. If I say float, then it's not like that everything should be float here. You can't take here int. No, int can be basically promoted to float. If I take here L, suppose this is long, 1L. Long is allowed because long is smaller, double is larger. So long would be promoted to double. It's okay. So it will give you 1.0. See, still 1.0. So this thing you need to remember. This should be like compatible data, right? Not exactly double, but compatible. So you can take int here, short, byte, long, float. If I take here 1.1 f, so float is smaller, double is larger, right? In the hierarchy, first comes float, then double. So it's okay. Float would be promoted to double and it will give you 1 point something like this in double, right? So now you are aware about arrays, so you can easily solve, I guess, these exercises. In the first, there's an array, you have to find out the largest element. The next, you have to reverse the element of the array, then search for a specific element in the array, and the next is calculate the sum of all the elements in array. So these are exercises for you. Plus, as well as calculate time complexity and space complexity for all the programs. Right? Now, one more thing. There is a enhanced loop for each loop. So that is better than for loop, traditional for loop. In some cases, especially in traversal of the list or collections like arrays, list. So if you want to just traverse these things, traverse means you want to print all the values of the array. Then rather than using traditional loop, use for each loop or enhanced loop. We have discussed this thing also. So the syntax is this is traditional loop. How to traverse an array? From 0 till array length. So array name dot length, we have a field. So it will directly give you the size of the array and simply print the array. Array of indexes I. But this is enhanced loop, enhanced for loop, or you can say for each loop. Here, different from this, don't need to take a control variable. Like here we have I is a control variable. It is controlling this loop, plus plus and all. There is no control variable, no need to do plus plus and all, this updation and all. Just take a variable. Variable name is here element. The type of this variable should be same as the type of your collection. Here collection is array. So my array is of type int. So this type should be int, followed by colon, followed by your collection name. the list name or array name here, and simply print the element. That's it. You don't need to take care about the size of the array or plus plus kind of thing and all. So that's why it's simple one. It will just traverse the array. So the first element of the array at first would be assigned to this variable, and that would be printed. Then the next element would be assigned to this variable, and that would be printed. So this element is not the control variable. This will deal with the actual array data, right? So we will see now how to use this for each loop to print the array. Okay. Now there are some already in the library, some methods to sort the array. We have a method sort. Oh, sorry. You can directly use this and the array would be sorted. If you want to fill the array with a particular value, you have a method fill, just array name and the value. So it will fill the array with a specific value. If in the array you are having 50 elements, the size of the array is 50, and all the 50 elements you want should be 0 or 1. So rather than writing individually 0, 0, 0 50 times, you have a method in arrays. You can call this is a class fill method, array name and value. It will fill 0, 0, 0 50 times in the array. Copy of, if you want to copy an array to new size, it will create the copy of an array with a specified size. Binary search, I've told you now there are two searching algorithm, linear search, binary search. So if you want to do binary search on the array, you just call binary search, pass here the array name and the element you want to search, and you don't need to do anything. It will directly give you the result using binary search. So these are already there in the libraries, but we will not use these because obviously in interviews, if they ask you do binary search kind of thing, so it's not like that you directly call this in one line, that's it. No, they want that the logic. So we will first discuss all the searching, sorting algorithm. We will implement our own logic. We will see the time complexity, space complexity. Then after that, like when you are dealing, or if you got selected and you are working on a project and that kind of thing, then you can use these libraries or inbuilt functions for that kind of thing. But as a beginner only, if you start using these things, obviously if you're using the sort, so don't need to implement, you don't need to write down the logic for sorting. It will automatically sort. Then what is the use of the sorting algorithm? So first we will see how to write down the logic ourselves, and after that you can use this. So right now I'm just uh, giving you just a brief, I'm just telling you that okay, these kind of things also exist. You can directly call this. You don't have to write down your code, but don't do this. We will write our own logic for all the things. After that you can use these things, but later we'll discuss all the things, right? Now first let me just show you for each loop, and then we'll see. Now arrays we have discussed. Int array, there can be float array, there can be double array, there can be a short array, byte array, boolean array. So these are primitive types. So we can have arrays of primitive type, as well as you can have arrays of objects. Objects, we have a class, we create object of that class. So we can have array of objects as well. That thing also I'll show you. But first let's just get familiar with for each loop. Okay, let's update this array only. So let's just comment out this thing and uncomment this. So we are initializing the array at runtime with this. Now we want to print all the elements of the array. So again, we obviously either you can print something like this. Individually, you can print number at 0th index, 1, 2nd, 3rd, 4th, 5th, something like this. And before that, let's just print one more line. Array elements are. So if I run this, it will give you the output. It will first ask enter the array elements, and then these are the array elements. But obviously, this is not a great idea. Individually, we want to print this thing, so we can put in this in a for loop as well. Okay, now I will use enhanced for loop for each loop. So what you can do, this type of the array is int, just take element, or we can take any, you can write here element as well, or you can write here abc or I or anything. So let's take I only, colon, the name of the array. Name of the array is numbers. Simple. And here, simply print. Rather than 0, you want to print whatever the, sorry, not numbers I. See, here, if I write something like this, let's just delete these things. Numbers and this I. Let's see what happens. Enter values. Okay, see. So 1, 2, 3, 4, 5. Array elements are, it is giving you the exception, index out of bound exception. See, index 67, out of bound for length 5. But we haven't given any index 67. 67 is the variable, na? 67 is the variable in the array. I mean the value in the array, not variable, value in this array. So if you write something like this, so I would be 67. Now see, numbers. In numbers, first element was, we have given 67. So the first element would be assigned to this I first. So now I becomes 67 and you are writing numbers 67. So obviously numbers is of size 5. So there is no index 67. So that's why this I is here not the index. This I is containing the actual value of the array 67. So and exactly I want to print 67 at first. So rather than writing index kind of thing, to directly print I here. That's it. So this I is not a control variable like this here. It is not index. It's the actual value. That's why we take here. So you don't get confused. Element or data or item, this kind of, you can say that name. You can take I also, but you have to remember this thing. I is not index in for each loop. Now let's run this. Now see, array elements are, these are the array elements, right? Okay. So it's very simple, na? You don't need to remember I plus plus or the size of the array, nothing else. Just take an element of the same type as the numbers, colon, the name of the array, and simply print whatever the element is. But this for each loop is mainly to traverse the arrays or the collections. It will not give you the access to the index. It will not keep track of the index in this array. So we can't use it when you need to modify elements based on their position, based on their index. We can't use in that case. There we use traditional for loop. But if you simply traverse the array or the list, use this loop rather than traditional for loop. This would is much more simpler than the previous one, than the traditional loop. Okay, now let's see arrays of objects. So we have seen arrays of primitive types, but arrays of objects are also allowed. Suppose you have a class student and there we have simply two fields, name and roll number, that's it. Or you can have a method as well like display. And here we will simply in system.out.println, we are just simply displaying the name and this roll number, that's it. Now, how to create object of this? For a single student, I want to store the information, name, roll number, marks, or everything. So just put there. And for a single student you want to store, then simply we can create the object. We know simply the name of the class is student and the name of the variables s1 new and student. Simple. And if you are using that constructor, I hope you are aware about constructors. So we simply write here the name of the student is Jenny, suppose, and the roll number is suppose 22. That's it. But now in my class there are 60 students. Now it's not like that I will create 60 variables of class student type s1, s2, s3. No, I'll not create 60 objects. I will create array of objects. So yeah, that is allowed. How to create? Same. When you create array of primitive type, we write the data type, then this brackets, then the name of the array. Same here. Here the type is student. It's not int or anything. It's student. So class is like we can say the user defined data type. So student, then it's an array. Then name. So just name of the array I'm taking students. Any name you can take is equal to same new and student. Now you have to give the size as well. So here the size is suppose 60. Simple. So this is array of objects. It's not that much tough. It's same as here. Here also we take like numbers is equal to new int, and we give here 5. So same new, but here it's not int. The data type is int, but here the data type is what kind of object I want to create? Student type object. So the type is student. So that's why student and 60. Okay. Now internally what is happening? So in stack, in this case, like we are having like students. So main, this is main activation frame, and here we have students, a reference variable. And there is an heap part. It's dynamic memory, so that's why we are showing something like this. It can grow and shrink. So here we are having array of like 60 students, or let's take only 5 right now. Only 3. Let's take only 3. So array of 3 students, 1, 2, and 3 we are having. So it is referring to this. But now what is happening? It is reference to this actual array is here, but it's not like that. Here only the data is stored, like name and roll number for first student, name and roll number for second student, name and roll number for third student. No, these are array of objects. So this is itself object. We know. So actual array is somewhere else. Actual array you have to create somewhere else to store what? Name and roll number. So name here, here roll number. Name and roll number. Here we have name and roll number. So actual array you have to create. Sorry. Again in the heap, and this is now referring to this. This is referring to this. This is referring to this. This is actually happening when you are creating arrays of objects, right? So basically this students is the array of references of the objects, array of references. So these are simply references, not actual objects. So if this is a reference, array of reference, 1, 2, 3 reference are there. This is at 0 index, 1 and 2. So this will refer to the very first object when you create to actually store the data. And to create this thing, you need again a new keyword. So you access this thing. Here we have at first, if you haven't created anything, so here you have null, null, null at first, right? In the references. Now you have to create. So what you write here is, you will write something like this here. Student, sorry, it's like students, the name is students of this reference at 0th index. So it's students at 0. Now for this, create actual array. I mean actual object, sorry, not array, actual object to store name and roll number. So now to create, obviously we need again new, and type is student. So right here student. If you execute this line, when this line would be executed, then here one object would be created, actual object which will store name and roll number, and now this would be assigned, this would be referring to this. Right now these two are not available because we haven't created anything. This is still null, null. Suppose address of this is 1000, so here we have 1000. Address of this is suppose 5000, so this is here we have 5000. Base address 5000. Base addresses of this is 5000. Okay, this is the thing happening. Now for again, if you want to create for second student, so students at one location is equal to new, same, the name is, so the type is student. That's it. Now one more has been created. Here we have name and the roll number, and this would be here. So internally this is happening when you are creating array of objects. This is basically, student is arrays of, you can say more precisely if I say arrays of references for student objects. For student objects, 3 references are there. So 3 references, and actual objects are 3 you create, and there the values are to be stored. And now if you want to access this name, how you access? Because at first level we only have this 5,000. So go here, access this, then access this. This is how you access. So how you access? You will write students 0. Students 0. So you will get here. Now this, then dot name I want to access. At this name, at 0 roll number I want to access. So dot roll number. You want to access this, then students, this is at index 1. So students 1 dot name, students in subscript 1 dot roll number, like this you want to access. So arrays are flexible. You can create array of primitive type, you can create array of objects. Okay, let me show you this thing practically. So within this only, let's create a new class. We have a class student. So we have just name, roll number, and we have one method to display this thing. And there's no access specifier I'm using. So these are by default having default. So package private. Within this package, we can use this in any class. Okay, these are not private. So we have this class student. Now I want to create, we have a main. This is our main. So in this main, I want to create, let's just comment out everything else here. And after this, I want to create object of this student, array of this. So we have created an array of objects. It's like this is a reference, so it's array of basically references of student objects. Okay, now you do one thing. If you want to print this students, let's run this and see. So in students, what we are having right now is, see, this bracket, then L, then com dot Jenny's lectures dot basics dot, I mean the name of this class student in Jenny's lectures dot basics of student, then at the rate something. Okay, so this is like bracket, or this is like array of objects. So it's L, so array of objects. Okay, now if you think, let's just print here students and 0. Simple. What is at student 0? So let's run this. I don't want to print students, but student 0. So here we got, that would be null. See, null. Because student 0, so itself a reference. It is array of references. So student 0, student 1, student 3. At this arrays, we are having references to the actual arrays, but you haven't created those actual arrays. So now create first those actual arrays. So it's students 0 is equal to, now create at this location, allocate the size, new memory using new keyword, and student. Simple. Now if you go for student 0, you will get some memory address, because we have created actual object, and see the name of the student at the rate some memory address is there. So there is some memory address. Now there is no values. So values you can assign something like this, like students 0 dot. Now you can access, see, name and roll number and display as well. So name, at first name. Name is equal to Jenny. And roll numbers. If I don't want to initialize roll number, I just want to initialize with name only. So student 0 dot name. Access this. As well as roll number. What do you think? What it will be printed here? What will be printed? Let's pause the video and try this out. Think about this. So name is Jenny, but roll number is nothing. So roll number is 0. By default, int value is 0. So that would be initialized. Those objects would be initialized, or these are instance fields. So instance field would be initialized because these are class level variables with the default values. For string, it's null. For int, it's 0. So roll number is in this case 0. Or you can assign roll number here. Now it will give you name is Jenny and roll number is 9. See. Same like for all the three objects you can assign. Student 1 dot name is this. Again, now create. It's not like that you can write here students like 1 dot name is equal to, let's assign something here. Let's assign here Pradeep, and I want to print this also. Students one dot name. Let's run this. See, null pointer exception here. Cannot assign field name because the student one is null, right? So this is a null pointer exception. If you click here, you will, the cursor would be here at this line here. See, the student one is still null. Only student, for student 0 you have initialized, you have created the actual object. For 1 you haven't created, this is still null. So first you create like this. For student 1, allocate, actually create the object of like creating, how to allocate memory using new keyword and the student, the name of the, obviously the class. Now you can assign here. Now it will be fine and it will give you a name of that student also. See, okay. So this is how we can create arrays of objects. So here if you calculate time complexity in this case, so we are not iterating over any loop and all. So time complexity would be, every statement would take constant time to execute. So it would be order of one only. Okay. And the space complexity here is, we are creating an array. So it depends on the size of the array. So definitely it would be order of n only. So we are done with arrays and objects. Now, what are advantages of array? If I ask you, then I guess you can easily tell the advantages of arrays. Performance, arrays offer efficient memory access. Directly you can access any memory location randomly. So definitely it's good. It's simple. It's linear data structure. So it's not that much complex. You can easily study this. So it's simple to, you can say, understand. It will provide a simple and straightforward way to manage the data. Flexibility, arrays of primitive type, arrays of objects you can create. So these are flexible. But if I ask you drawbacks of arrays, I guess that also you can easily say. Like, arrays will have elements of same data type. You cannot store mixed data type like in Python we have, but it's Java, it's not Python. Then we have arrays are of fixed size. Okay. Next, insertion and deletion in array. It's really tough. I'll, in the next video you'll see the operations on array. Then you will get it. Like insertion and deletion are why I'm saying it's tough. So fixed size, memory overhead. Now obviously it's of fixed size. Now if suppose you have allocated an array of 60 arrays of size 60 of int type. So 60 into 4, that much memory would be allocated. Memory for 60 elements would be allocated at first. Now actually you have stored only 10 elements. So you have used only 10 into 4, that is 40 bytes. Allocated word 60 into 4, 240 bytes. So the remaining 200 bytes are wastage of memory. So that's why. Because initially we don't know. Array size, we generally take the maximum size. But maybe we don't use that all the size, I mean the complete size of the array. We don't store 60 elements or whatever maximum size we have given. So that is wastage of memory. Rather than you use dynamic kind of thing. So based on your requirement, array, the size of the array should grow and shrink. So that is array list or the linked list. Okay. So see, that's why inefficient for dynamic data. Dynamic data means when you are dealing with the data that changes in the size, then arrays can be inefficient. So for that we have different alternative, that also we'll see. Alternative of arrays, array list we can use. We'll see that thing also. It's a dynamic array that can resize automatically at runtime. Linked list also there. This is also good to store dynamic data. Hash map, these are also great thing. So we'll see one by one all the things in later section. Don't worry. Okay. And in many of the lead code questions or whatever question you, the interviewer will ask, many of the question, DSA question will use array list or like hash map to get efficient time complexity or less time complexity. Right. Now, choosing the right data structure. Now, why to use arrays? Now you know the size of your data. Data is of fixed size. And randomly you want to access the data. If you need that, I want to randomly access the data, then use arrays. That's good. But For dynamic data, it's not good. And if you want to insert, if you want frequently insertion and deletion in your data, then also array is not sufficient, not efficient. For that, linked list is better. We will see this thing, insertion and deletion. So I hope now arrays are clear to you. These are the basics of arrays. In the next lecture, we will see operations you can perform on arrays: insertion, deletion, traversal, searching, reverse of array, and these things, and the time complexity and space complexity required. Okay, mainly we'll focus on time complexity, not on space, right? So that's it for this lecture now. I hope you got this. Now I'll see you in the next lecture. Till then, bye bye. Take care.